Right, so today we're going to have a look at compound measures. To begin with, we're working out an average speed. So we need to remember the formula that speed is equal to distance over time. From that formula, we can fill in our triangle, speed, distance, time, and that now tells us every formula we need to know in order to answer this question. So it tells you that his distance was 15 and his time was 6 hours. So speed must equal to that 15, that distance, divided by time of 6, and we get the answer 2.5 miles per hour. Question 2, very similar. Draw out our speed, distance, time triangle. So this time it's told us that we've got an average speed of 80 kilometers per hour and he's driven for 3 hours and 45 minutes. To begin with, we need to convert that time into a decimal. So we know 3 hours and 45 minutes. Well, 45 minutes is 3/4 of an hour. 3/4 of an hour is 0.75. So therefore we must have 3.75. We've been told what the speed is, we've got the time, so our formula tells us that we must multiply to get our distance, it must be our speed times our time. And we get the answer 300 kilometres. So the driving distance between Manchester and London is 195 miles. He wants to go by coach, and the coach leaves at 3:30 p.m. He assumes that the average speed will be 50 miles an hour, and he wants to know what time he'll get there. So we've got our speed, we've got our distance, and we need to work out our time. Again, we're going to cover the one which we're trying to find. So that means time is equal to our distance divided by our speed. This is equal to 3.9 hours, which is equal to 3 hours, and we need to work out what 0.9 of an hour is. So in order to do that, if you do 0.9 times by 60, it will tell you how many minutes 0.9 hours is, which is 54 minutes. So therefore we know it will take him 3 hours and 54 minutes. Our final step, it wanted to know when he would arrive in London. Well, he left at 3:30 p.m. So if we add an extra 3 hours to that, that's 6:30 p.m. If we add 30 minutes, that's 7 p.m. and we've got 24 minutes left. So therefore, he must get to London at 7:24 p.m. It then says the coach has a lower average speed. How does that affect the arrival time? Well, his arrival time will be delayed, or it will be later. As he isn't going as fast, therefore it will take him longer, so he won't get there as quick. So it will be after 7:24 p.m. Our next question involves mass, density and volume. So straight away we highlight the units for density. This tells me that density is equal to grams, which is a mass, over or per centimetres cubed, which is a volume. I didn't remember that formula, however I've got it just from my units. So now I can draw out my triangle, just like my speed, distance, time triangle. And then I read the rest of the question. It wants me to work out the mass in kilograms. So I've got information about the density, and then I've got this picture. So first of all, I need to work out the volume of the cuboid. The volume is the cross-sectional area, so 3 times 5 times by the length, which in this case is 10. That is equal to 150 centimetres cubed. At this point here we check our units match, which they do, because our density is in grams per centimetre cubed. So now, to work out the mass, our triangle tells us that it's density times volume. Our density is 9.86 times by our volume of 150, and we get the answer 1,479 grams. Then just read the question carefully. It wants it in kilograms. So now we convert it to kilograms by dividing by 1,000. And that gives us our final answer of 1.479 kilograms. So our next question again is just a speed, distance, time question. So we've got our distance is 156 miles. We've got our speed of 60 miles per hour. And we want to work out the time. So time is equal to our distance, 156, divided by our speed, and that's equal to 2.6 hours. Again, we need to work out what 0.6 of an hour is. So we do that by timesing 0.6 by 60. That tells us that it's 36 minutes. So in total, our time is going to be 2 hours and 36 minutes. So now, finally, we read the question. She leaves at 7:30. So 7:30 a.m. If we add 2 hours to that, that's 9:30 a.m. If we add half an hour to that, that's 10 a.m. And then we've got the final 6 minutes. So she will arrive at 10:06 a.m. Does she arrive in London before 10 a.m? No. Okay, question 6. Again, looking at our mass density volume. So again, we can get our formula for density by looking at our units. So density is mass over volume. Then it's told us we've got a cuboid 1 metre by 0.6 metres by 0.3 metres. Just be careful. They sometimes do this in exam questions where your units are different. So straight away, before we work out any volumes, we're going to change this into centimetres. So it'll be 100 centimetres by 60 centimetres by 30 centimetres. Now we can work out the volume of the cuboid by multiplying these amounts together. This is equal to 180,000 centimetres cubed. Now we can work out our mass. Our mass is our density, 2.7, times by our volume, which is equal to 486,000 grams. Again, read the question carefully. It wants it in kilograms, so we divide by 1,000 and we get our answer 486 kilograms. Our final question, and by far the hardest question you will get, probably one of the toughest questions you'll see on your GCSE paper involving this mass density volume. So it's told you 3 bits of information. We've got density of apple juice, density of fruit syrup, and density of sparkling water. It's then told you the volume of apple juice, the volume of fruit syrup, and the volume of sparkling water, with the total volume of the entire drink. And it wants to know the density of the drink. So at the moment we've got our volume of the drink and we want to work out our density, so we need to know the mass of the entire drink. Well, in order to get the mass of the entire drink, we need to get the mass of each component. So I'm going to number these 1, 2 and 3. So looking at apple juice first of all, we've got our density is 1.04, we've got our volume is 35, and again our formula here is key. So we want to work out the mass of each of our components. So our mass must be our density, 1.04, times by our volume. That's equal to 36.4 grams. Exactly the same process for number 2. We've got our density is 1.6, we've got our volume is 25, so therefore our mass is 1.6 times by 25, which is 40 grams. And then finally, our third part, we've got our density is 0.99, our volume is 270, so therefore our mass is 0.99 times 270, and that's equal to 267.3 grams. So we want to work out the density of the entire drink. We know density is equal to mass divided by volume. Well, our mass is the combined mass of each of our 3 parts. So we need to add our 3 masses together. This is equal to 343.7, and we're dividing that by our total volume, which it's told us is 330 in our question. So now we work out the answer, and we would have our density is equal to 1.042 to 3 decimal places. So I've already rounded that up, so it's 1.042, and then we don't forget our units, which is grams per centimetre cubed.